Hello all, we'll be starting in a couple of minutes. We have three important algorithms to cover, and more than three important algorithms, they are one of the best questions of the arrays which any interviewer can ever ask. We'll begin in a couple of minutes. Let's others join. Until then, we'll wait only. So after this class we'll be having three more classes. Those three more classes will be of mostly 2D matrix and all, because most of the algorithms of arrays we have covered till this point of time. A couple of more are left. I'll take that in upcoming classes. But I have three algorithms lined up for the day. That is not algorithms, they are majority, they are questions only. The first one is rainwater trapping problem, that is of hard label. Second one is max chunks to make sorted, that is of medium level. And third one is majority element, that is also algo called I don't remember the name, that is a voting algorithm, Buis or Bui, something like that. That is some kind of voting algorithm. So we'll wait for we won't wait now, we'll basically start. I'll start with this max chunks to make the array sorted. Okay, I'll start with this particular question. So to begin with, we are given an array, and that array, the question number for the lead code is 769, and the question name is as max chunks to make array sorted. If you see the question states that you are given an integers from range 0 to n minus 1, that is inclusive integers range. Okay, and they are jumbled up. You need to return number of chunks to make array sorted. I know question is bit confusing. I will explain with an example, with the help of an example. So just imagine you are given with so for dry run, if you go, so for dry run, not we will explain the problems with the help of example. I will explain. So that is, the question is 1, 0, 2, 3 and 4. So the question is asking, we need to return the maximum number of chunks, to make the array sorted. Okay, fair enough. So the maximum number of chunks we can make over here is 4. Okay, how we are saying that? Okay, maximum number of chunks over here is 4. So basically we need to draw a imaginary line. At for one chunk we need to draw one imaginary line, and if we sort those lines, if we sort those intervals, these intervals, the array itself will be sorted. But we need to return the maximum. If suppose they were asking for minimum, I will discuss what could we have done for the minimum intervals. but they are asking for maximum number of intervals. Okay, I'll so if you know, if you sort this up, so this could be 0 comma 1, so this is one chunk. If you sort separate 2, separate 3 and separate 4, in return they are 4 chunks and they are making the array sorted. They are making the array sorted. Just 1 second, boys. Okay, so sorry. So these are so if you don't need to draw these imaginary lines, you just need to return the number of chunks: first chunk, second chunk, third chunk and fourth chunk. These are 4 chunks. If you sort these chunks at their specified boundary, they will give me the they will return me the sorted array. Okay. So if you I hope the question is not clear to you. I'll give one more dry run to it. I'll write a couple of more examples. So imagine this as array as 1 2 0 4 6 5 3 7 8. So over here, to understand very carefully, if you carefully observe, if we sort all these three, this will make one chunk. If we sort this, the array will look like 0 comma 1 comma 2, right? If we sort this particular chunk, if we make this as a chunk, the array will be sorted over here. If we sort these 4 elements together, so this will give us like 4 5 6 7, right? And if we sort them separately too, because we have to maximize the chunk, we can also say that okay, these two can be together, but we don't want them together. We want maximum number of chunks. If you read the maximum number of chunks, okay. So if we sort these 3, na, if we sort these 4, if we sort this and if we sort this, you could have asked me that what could we if we have taken these two together, saying that this is a chunk. No, they can't be they can't return a sorted array, just because if you might have taken this 1 and 2, so they could have been sorted like 1 and 2 only over here, and 0 might have been in a separate chunk, so it could be sorted over here in this place only. In this place they are sorted, in this place it is sorted, but at the end of the day array won't be sorted, because this 0 needs to come in front of this 1 and 2. So you need to sort such that at the end of the day, if you sort those chunks up now, if you I am sorting these chunks 0 comma 1 comma 2, okay. Again if you sort this chunk 3 comma 4 comma 5 and 6, if you sort this 7, if you sort this 8, so maximum number of chunks possible here is 1 2, this is 2, this is 3 and this is 4. I am writing the count, I am not writing the, so maximum number of chunks over here can be 4. Again I will explain one more example to make this pretty much clear to you guys. Suppose this is the array given. So now can you let me know that in what chunks, can be the maximum number of chunks? Maximum chunks we can divide this array so that at the end of the day array is sorted. Array in output array could be like this: 0 comma 1 comma 2 comma 3 comma 4 comma 5, right? So maximum chunks, can you let me know what can be the maximum chunk over here in this particular problem? Anyone? Anyone can let me know that what can be the maximum number of chunk in this particular array? Come on guys. 1. Correct, 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 proper, accurate answer. Because if you carefully observe na, we need, if we could have taken like this na, we said okay this is the one chunk, but if we sort this up we won't be able to get the sorted array. So we need to sort that chunk, this complete array, we will be considering this complete array as a chunk, array as a chunk, right, array as a chunk, right. Why? Because if we sort this complete array at its own place, there is no, like, we can't distribute somewhere like this, somewhere like this, somewhere like this to make this complete array sorted. We can't make this as a chunk, because if we make this as a chunk, suppose if we make this as a chunk, they will sort in place 2 3, but 4 5 can't go back, right. The chunk should be at their place only, they just need to be sorted. 2 3 can be sorted over here, this can give you one chunk. If suppose if okay, tell me one more answer guys, okay, tell me one more, I will do one more dry run. Okay, for this what could be the output? Can you let me know for what will be the output for this array? How many chunks can we get, maximum chunks? So the maximum chunk over here might be, this 2 can be sorted over here at their place, this 2 can be sorted over here at this place, this 2 can be sorted over here at this place, right. So it could be this 2 giving me 0 comma 1, this 2 giving me 2 comma 3, and this 2 giving me 4 comma 5. So maximum chunk over here can be 3, right. Great, great guys, great. So that this question seems very easy to solve, right, but it can't be. Like, if suppose I'll give I'll make the problem more funnier, I'll make you understand. I don't want me to solve this problem, I want you guys to solve this problem. Okay, no problem, I'll make this question little bit funnier. So imagine this is one more array, okay, and just imagine guys that if over here 6 comma 7 is there, then what could be the chunks? Correct, you might have guessed it correct. This one is 1, this one is 2, this one is 3, 4 and 5. So the answer for this will be 5, right. I hope that up to this point you could have got the question. If not, repeat it. Okay, now comes the algorithm. So now comes the algorithm to observe this particular point. So if you carefully observe, I'll pick one of this, I'll pick this one, okay, and we'll try to solve this up. Okay, so if you carefully observe guys, if you carefully observe guys, over here I'll write the indexes in red: 0 1 2 3 4 5 6 7 8. Okay, so just bear with me for a couple of minutes. So we'll say we'll be maintaining two counters. The first counter is chunk counter, that will be initially 0, and the second counter will be index counter, that will store the maximum index value index. Okay, I'll explain what value index means over here. Okay, just bear with me. Okay, so if you carefully observe, guys, I'll meanwhile I'll erase a couple of things to make sure that okay, you guys are learning well. Okay guys, I can't I need to take this call. हेलो पापा, हम हैप्पी बोल रहे हैं, बोलिए ना, क्या हुआ, बोलिए ना। हाँ हाँ ठीक बा, ठीक बा। हेलो, यस गाइस, ओके। Okay, so if you carefully observe, if I am getting 1 over here, so I am pretty much sure up to index 1 I need to get this chunk, yes or no? Initially till index 1 I am first getting index 1. Okay, I'll do a dry run. Okay, so if I am getting 1 over here till index 1, I need to carry this, right or wrong, yes or no? Yes, till index 1 if I carry it, because if suppose if this element might have been 0, till then if suppose this index might have this element might have been 0, still we need to carry this chunk up to index 1 because we have the element as 1, so we need to carry this till first index, yes or no? Yes, if we have this as 1, so we need to carry this till this point of time, we can carry as 1, correct? So we'll do chunk plus plus for the first time. Our chunk now is 1 and the max index is 1, correct? Correct. Now if we move to this index, if this is coming 2 is coming, now it's 2, so we need to carry our chunk until index 2. We need to enlarge our chunk until 2, because until second index we need to sort this, so we need to take these 2 in our indexes, so that on sorting, if we don't take these 2 on sorting, what we want this 2 as over here, so we need to carry this 2 up to index 2, yes. So our chunk will remain same, but our maximum will be updated over here. Our maximum index will be, max index whatever it is, max index will be 2, so we need to carry it until 2, yes or no? So we have carried this until 2. Now is this 0 enforcing us to do something? No. So we have reached our maximum index, and we have reached our maximum index, guys, right? And our chunk, we won't consider our chunk anything, we have reached our maximum index. So once we reached our maximum index, which all the rules, our rule is until the maximum number comes, that will be our maximum index. So just imagine, so we can till where we can create this chunk, we can create this chunk up till 2, because we need 2 in our this chunk, right? So once we cross our maximum index, our maximum index is 2, we will do one more chunk plus plus, C plus plus will do it, okay, and now our maximum index will become 3 just after. So we got this as a chunk, right, yes or no? We got this as a complete chunk, okay. Just hold on, guys. Okay. We need okay, so once we cross our this chunk, we need to increase our maximum index to the next index, okay, and our chunk becomes now 2, and we are in search where our chunk 2 will be ending. We are in what we are searching now, where our chunk, this chunk, this ongoing chunk is about to end, so this says we can end it up to 4, this index says, because this is 4, so we need to take this at index 4, right? So this element says that our maximum chunk can go up to 4, but as soon as we are going on this index, this says we can end this up till 6, we can end this chunk at 6. So our maximum is 6, 5 is less than 6, no problem, we don't do anything. 3 is less than 6, yes, it is less than 6, and once we reach 6, our one more chunk is defined. Yes or no, guys? Completely yes. So over here our chunk becomes 2. Now if we again move, if we cross our maximum chunk index, that was 6 earlier, if we cross our maximum chunk index, that was 6 earlier, because we said okay, we need this chunk till 6, we need this chunk till 6. Now comes our next thing, we will be making this maximum chunk as 7. So maximum index as 7, so we need this, we make this as a 7, and once we made this as 7, so is it enforcing something? No. Is it enforcing something? No. It's saying okay, it's 7 and maximum chunk is 7, we do C++, that will be 3 only, and once we again move, we'll do C++, it will be, because at 8th index it will be 8 only, maximum chunk, we have increased our maximum chunk to 8, and it will give us maximum chunk as 4. Had this example been something like 8 and 7, so up to here our count was 2, once we could have increased our maximum chunk to 7, once we have crossed that our this specified chunk, we could have made our maximum chunk as 7, right? Over here had this been 8 and 7, so as soon as we landed on 8, we say okay, our maximum chunk could have become 8, right? Yes or no? It could have become 8, it could have become 8, and this 7 doesn't matter once we cross this. So if had this example been like something like this, so our maximum chunk would be 1 over here, 1 over here, and 1 over here. So this is the basic dry run. I'll do one more dry run, so that, so I'll just make sure. So I'll write an example which will make you more clearer. Okay, I'll write an example, and meanwhile I'll start the like dry run. So just suppose if you have, if you start with if the array goes like this, something like this, okay, so if you have 2 over here, so what this 2 suggests, guys, this 2 suggests until index 2, until suppose I'm writing just indexes over here, 3 4 5 6 7 8 9 10. Okay, so if we get 2 over here, guys, so this suggests until index 2 we need to carry forward our first chunk to make this 2 as the get back its correct position. So this is suggesting this only, but just suppose after this 2, here it comes 3, so will our chunk count increase? No, it won't increase. It suggests that we should make our chunk so that large, we should end our chunk at 3 only. It suggests that we should end our chunk at 3. What if it could have suggested 4? So that could have been suggesting that we should end our chunk at 4th index. At our 4th index, this could have suggested. So if you go with this example, what this 5 is suggesting, guys, okay, what this 5 is suggesting? This 5 is suggesting we should end our chunk at 5th index. What this 1 is suggesting, guys? This is suggesting that we should end our chunk at 1st index. So as soon as we move our maximum index, we will increase our chunk plus. Then what this 3 is suggesting? We should increase our chunk window till 3. What this 5 is suggesting? This 5 is suggesting as soon as we get the higher number, our chunk size will be increasing, and if we are not getting higher number, we will store that higher number, we will store that maximum number in a max index or whatever it is, and then as soon as we cross that maximum index, we will increase our chunk. Is this question making sense to you, guys? I think only 2 people are there So whosoever is there, I don't care. Is this approach making sense to you guys? Let me know if this approach is making sense to you guys. Yes, yes, okay. So the code is very basic, straightforward, but the logic was pretty much simple for you guys. So the question number for the lead code for the same question is 769, and I hope that you will solve that question today only, such that you make sure that okay, this question, this particular chunk type question. So this is this is one of the best examples of carry forward technique. I taught that technique earlier only. So this question I taught a little later, but this is one of the most, what we are carrying, we are carrying the maximum window up to where we can sort our chunks. Okay. So that's it for this question. We'll move to other question. Next question, guys. So our next question is also one of the best problem. So that is called as, I'll Google the name. What it is called, I don't know. Yes, Boyer Murray voting algorithm. Yes, that is what it is called. Okay. So the question is very plain and simple. It's also there as majority element on lead code, that is 169. I'll yet it call it as Boyer Murray majority voting algorithm. I'm not writing the count. I'm not writing everything, like every code for this. I hope that you are that much proficient to write code for everything. I'm making sure that okay, you understand the algorithm, you understand how the logic is working, you write code for yourself. Okay. If you go for Boyer's voting algorithm, they are saying, so the question states, find the element which appears more than n by 2 times in the array. So that array could be like this. So the array so first example is, array is given as 2 2 1 1 2 2. So the brute force what we can do is we can create a hash map saying that okay, 1 is coming 2 times and 2 is coming 4 times, and then we can iterate over hash map and say if the frequency of a particular element which is there in hash map is more than 3 or equal to 3, then return that element, right? Because we have the array as length 6, 0 1 2 3 4 5. Okay, but that could have taken order of n extra space, that could have taken order of n extra space, but we don't want to solve that problem in order of n extra space. So the algorithm goes plain simple. We have a couple of more examples, like something like this, something like, I'll take a different type of example, something like this. Okay, 1 1 1 2 3 5. Over here 1 is coming 3 times, like we will add one more 1 over here. So this is basically majority element concept comes from a voting algorithm. Just think of a voting, how voting is considered in your particular area. So have you ever done something called cancel out? Suppose you gave your friend 50 rupees, and for the first time friend B, A gave to his friend 50 rupees to his friend B. Okay, but sometimes B gave party of rupees 100. So how we will be calculating is that, so earlier B was in depth of 50 rupees and A is like giving the party of 100 rupees. So B will say, B is giving the party of 100 rupees to A. So B will say that okay, 100 minus 50 is cancelled out. 50 is cancelled out. Okay, 50 is cancelled out and only 50 is remaining. So this is how the cancelled out technique works. So over here we will be using that cancelling technique only. So what we can do is, I'll teach you what we can do. So we will consider anyone is in profit now. Over here we are considering 2 is in profit. We'll increase the count, we'll save the number will say 2 and count will say 1. Okay, if the next number is 2, we'll increase the count to 2. If the next number is something other than 2, we'll decrease the count as 1. Again the number which is, it's not 2, we'll decrease the count to 0. As soon as we decrease our count to 0, the next number, whatever the next number it will be, that will be our maximum number. Over here it is 2 only, so that could be, over here it will be 1, it will be again 2. So this 2 is our majority element. But if you go in this case, if I jumble this, we'll take different examples, just don't worry. So over here our number is this and our count is this. Our number is 1 and our count is 1 for the first index. Second index if we go, count will become 2. Third index we will go, count will become 3. Fourth index if we go, it's not 1. So we don't care if it is anything other than 1. We don't care. We just make sure that if it is not 1, we will decrease our count. Our count will decrease to 2. Index comes over here. It's not 1, we will decrease the count to 1. It's not 1, we will decrease the count to 0. As soon as our count becomes 0, the next element becomes our maximum number, that is greater than n by 2. The frequency of that element should be greater than, so the next element is 1 over here, so it will become our maximum number, and that is 1. So whatever the number ends at the end of the array, that will be our maximum number. Just suppose you might have been thinking like this. So if like something, this is like there. Okay, so over here count becomes 1, number is 1, count is 1, count is 2, count is 3, count becomes 4, not 1, count becomes 3, not 1, counts become 2, not 1, count becomes 1. So we are cancelling one vote with every other vote. It doesn't matter that to whom this person is voting. This particular person voted to candidate 2. Okay, so we cancelled out these votes, we cancelled out these votes, we cancelled out these votes. So at least one guy will be remaining, which will remain at the end of the array. So what I mean to say is that we are just cancelling out. This technique is just cancelling out each and every single thing. We are maintaining a count as soon as our count becomes 0, as soon as our count, so we'll take one more example. Wait, let me take better examples. I'll ask ChatGPT to give me better examples for this. Just hold on, I'm not having good examples. Just hold on, guys. Okay. Okay, so over here if you go with the other array, that array is 7 7 5 7 5 5 7. So this array is a little bit trickier array. So for what we'll do, we'll have two things, number and count. First time we go and say number is 1, count is 1. Again we go, we say our number is number is 7, count is 2. If we go over here, we'll decrease our count to 1. We go over here, we'll increase our count to 2. We go over here, we'll decrease our count to 1. Okay, we go over here, we'll decrease our count to 0. As soon as our count becomes 0, the next element will be our number, be it, suppose if it is the continuation array and this element is x. So our number could have been become x and count could have been become 1. Once you parse all the array, what is the number, just count that as a number. Just make that as majority number. At the end of the day, what stays in the number, make that as majority number, and completely go through this array and see if that array, if the numbers frequency is really more than that what n by 2, then return that number as a majority number. I'll explain one more example. Suppose if we have given something like n is equals to 1 2 3 4. In this example, what will happen? This will clear every doubt of yours. So our number is 1 and our count is 1. As soon as we go to this, our count becomes 0, and as soon as our count becomes 0, no problem, we will move to next number, and next number is 3, and our count will become 1 over here in this index. As soon as we move to this index, this is not 3, so our count will become again 0, and our array ends. Now comes the trickier part. Is 3 the majority number, majority number / vote? No. How we can verify this? This 3 stays at the end of the array, but to verify this, we need to go in that particular array and count how many times 3 is coming. If 3 is coming more than n by 2 times, return. So this technique basically works on cancelling out. If I have 1, the other person is voting to 2, the other person, again he got 1 vote, the other person votes to 3. So we are cancelling every vote, and at the end of the day we will see, okay, 1 vote is extra in this favor. So that means that this guy is winning the election. Is this concept clear to you guys? Is this concept clear to you guys? Is this concept of voting algo is clear to you guys, or you want more dry run? Come on guys, reply. Is this concept clear to you guys, or you want some more dry runs? You don't want, I just explain. Is this concept clear, or you want more dry run? More dry run. Okay, not clear. Basically you are saying if the concept is not clear to you, something like this. Come on guys, write it quickly. More dry run, then we can take a couple of more dry runs too, no problem. Not clear, not clear. Okay, okay. Guys, you are getting this particular problem. This particular problem is literally very of high intensity, and you are not getting this easier problem. My God, no problem. We'll do a couple of more dry runs to check. Array is given like I'll take suppose 1 1 1 2 1 2 3 2 2 2 2 3 2 2. So basically 1 2 3 4 5 6 7 8. Okay, let's check who comes as majority element. I'm just checking an example. So we'll have two things at the end of the array, number and count. First of all, what we'll be doing, we'll check, okay, at the first index or any index we are having count as 0. Initially we'll set our count as 0 and number is nothing. Okay, we'll reset the number as soon as we get the count 0. Okay, that is the only thing. For the first time, if we go, the number is 1, we'll set the number as 1 and we'll say our count now becomes 1. Okay, again if we go, our count becomes 2, same number. Again if we go, our count becomes 3. Up to here it's clear. Okay, now the number is not 1 because we are having 1 as number. Initially up to this point, who is winning the election? Up to this point, who is winning the election? 1 is winning the election, because till this point of time we have 3 votes. No, not 3 votes. We have initially 3 votes, but as soon as we reach the index, this index, our vote could have become 2. We have cancelled out 1 vote of 1 to 1 vote of 2. So who is winning the election? 1 is winning the election up to here. Now our counts become 2. We check for this vote is again 1 and the number is 1, so we will increase our count to 3. Now if we check over here, it's saying the number is as 2 but our number is 1, so we will decrease the vote count to 2. Again if we see over here, it says the number is 3 and our number is 1, so we will say no, it's not the same case, so we will decrease our vote to 1. Again if you go up to here, it's not the same number as 1, so we will decrease the number to 0 as soon as our count becomes 0. As soon as our count becomes 0. So there are two cases. If the count becomes 0, yes, as soon as our count becomes 0, as soon as our counts become 0, okay, no problem. From next question onward, next point onwards, Ankit, I am sure of question, I have solved this question at least 10 times. Just hold on, learn the algo. Directly comment over here so that I don't need to go to WhatsApp and check every time. Comment over here, no problem. Just understand, just try to focus. As soon as our count becomes 0, no problem. So as soon as our count becomes 0, we'll go to the next number. We'll go to the next number and set that number as our majority number. So now our number become 2. We'll again go and our count will become 1, because this is coming now 1 time. Up to here, how many times 1 came? So if you focus over here, how many times 1 came, that many times only the other numbers came. Let's justify this, because our count becomes 0. So 1 is coming 1 2 3 4 times, and how many time other numbers are coming? 1, 2, 3, 4 time. So 4 and 4 got cancelled out. That is why all the votes in this area got nullified. Not nullified, they are like have a mixed judgment. Okay, up to here we can't say that one is winning the election definitely. We can't say this. I am not saying that one is winning. If suppose all the votes might have been gone to 2 only, if suppose all the votes might have been gone to 2 only in this area, then that it could have been 1 versus 2 draw, 4 and 4 votes to each one of them. I am not saying that okay who is winning. I am saying one is not winning definitely in this particular zone, because 1 becomes 0. I am not saying, if suppose we can't guarantee it. Okay, that 1 is guaranteedly winning this election. We can't guarantee it. I'm just saying, remember my word, I am not guaranteeing. But once we reach at this index, our count have been become 1. For this index, what could have been our count? Because it is the same number, so our count could have gone to 2. Again if you go 3, again if you go, no, it's not the same, so we'll decrease our count to 2. If you go to this index, it says okay the number is same, it's 3. If you go, it's 4. So it is saying our count is now 4. Doesn't matter, we don't care about count at the end of the day, we just care about the number. So the number came as 2. Okay, our number came as 2, guys. So what we'll be doing, we'll check. Now we'll re-verify that okay 2 is the case which is coming n by 2 more than n by 2 times or not. So we'll just in the next iteration, for the first iteration we find out that okay the number coming is as 2. So this was the half part of the question, to find the number. So number came as 2. Fine. Now reiterate through over complete array. Check. If it is 2, you need to find how many times 2 is appearing in this array. So up to here we are finding that who is winning the election through this algo. Now we need to verify that okay.
Sure how to help you with that.
Up to here, up to this point of time, we were not sure who will win the election. At the end of the algo, it said that okay 2 might win the election. Just re-verify the count of 2. Okay, 2 might get more than n by 2 votes. Okay, for Ankit is getting confused with n by 2 votes. I am guaranteeing that okay he will win or not. Okay, if you are getting okay suppose okay let me do one more thing. So if suppose leave everything. If suppose a constituency is having 100 votes. A constituency is having 100 votes. So if any candidate gets 51 vote, then it is guaranteed that he will win. Because if suppose all the 49 votes, suppose 3 candidates are there, A, B, C. If any of the candidates, suppose B got 51 votes. So if all the candidates, if any other candidates, then we like if we got 51 votes, no more than n by 2 votes, then we can guarantee that B will win the election. Because if suppose the only number left is 49 votes are left, okay, B got 51 votes, so A plus C might have got 49 votes. If suppose A got 0 vote, then also C is getting 49 votes and B is getting 51 votes. It is a guarantee, sure short guarantee that B will win the election. So this is the trick behind it. I don't know whether you guys are getting the trick or not. So where were we? We were about to find that we got the n. For the first time we were considering only n. What is the n? As soon as we found n is 2, so we will do one more iteration. We will check, okay, count of 2, we will check the count of 2 will come in the array 1, 2, 3, 4, 5, 6, 7, and it is definitely greater than n by 2. You count it, but over here if you carefully observe, we got 4 as our n in the end, or 3 whatsoever, but is 4 winning over here? No. So we need to re-verify, cross verify that, okay, count of 4, as soon as we get the count of 4, we can verify that, okay, whether 4 is winning the election or not. If you go over here, our last elements came out to be 7. Our last element came out to be 7. So we went again in the array and check, okay, count of 7, 1, 2, 3, 4. So count of 7 was 4 and the array length is 7. So it is definitely greater than n by 2. Then it will definitely win the election. So majority element is 7 over here. If you go over here, our n came out to be 1 in this case. So 1, 2, 3 and 4. So this is definitely greater than n by 2, that is 7, right. If you check over here, our n at the end of the day came out to be 2, 1, 2, 3, 4, 4, and that is definitely greater than n by 2, that is 3. So 2 is winning the election over here. This is for sure. We are not bothering about what votes others get, we are just bothering about who is definitely winning the election. Whom can we say we are definitely winning the election? So the question over here in lead code is approaching something very different. It's saying majority element. The concept is same. The concept is of majority element only. The concept is of voting algo only, but the language for this particular question is different. We can get that language over there. Maybe I can share my screen and I will let you know. So it says that given an array nums of size n, the majority in element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So they are saying it is definitely existing in the array, and you can also find this in order of n square time. But do we need to find that in order of n square time? Do we need to find out? No. So like maybe I can code it for you. So this will be the last question if I am coding this. Do you want me to code this, guys? Only 2 people are watching the stream today. Very much sincere and serious guys are there in our class. Oh my god. Do you want me to code? Come on guys, respond. Guys, respond. Do you want me to code? I can code. Yes. Okay. Okay. So this will be the last problem. I won't teach rainwater trapping problem today. Then I'll be teaching this only. This will be the last question. I didn't. Okay. So what I told you, we'll be having one integer called n that will be initially pointing to anything like that will be pointing to not first, it will be pointing to nums of 1, okay, nums of 0, first index, okay, first index of the array. And what we can say our count is as 1, okay, because for the first time this will be the first element, and if this for that element only we will have our count as 1. So what we can do, we can int index is equals to 1, okay. So we can also write a for loop. Let's write a for loop only. So for int I not equals to 0, from here I should be equals to 1 and less than nums dot length I plus plus if we say count is equals to 0, this is one case, and else if count is greater than 0, okay. So if count is 0, we need to reset everything, and if count is greater than 0, then we can continue and we can check if nums of I equals to n, then we'll increase our count. अगर वो if it is not equals to n, we don't need to check that what it is equal to, we'll just decrease the count, that's it, okay. And if in any case count is equals to 0, so if in any case count is equals to 0, our n becomes nums of I and our count becomes 1, and whatever n will be at the end will reset our count to 0, and we'll check if that is existing really for n by 2 times or not. Then we'll check what? Count plus plus, and at the end of the day we'll be checking if count is greater than nums dot length. Now we'll just so over here it is saying you may assume that there is a majority element that always exists in the array, so we don't need to do this. If it could have might have said that okay, that there is chances that majority element is not there, then we need to do this. Suppose it for just for the example of this example, you remember, I'll just write the example 1 comma 2 comma 3 comma 4. Over here our n could have come as 4 or 3 whatsoever according to our algo, but over here there is no majority element, so we need to do this to check okay if really 4 or 3 whichever is coming through our algorithm is fulfilling the condition, then we could have done this. Over here we don't need to do this, we can just simply return n. I think that's it, we can check. Okay, one more thing is there, I just missed one case. I need to do one thing. If nums dot length equals to 1, return n, because over here n is nums of 0 only, because in some cases they will give a single array only, single length array. Just I am writing this, let's check. Okay, everything goes good, I'll just submit and see, have a look that literally in order of n time, this is the best. Like even if we go and if we say chat GPT, if we copy paste this and we'll say optimize, it will say that it's most optimized code, optimize this code. So your code is already Boyer's Moore voting algorithm, which is optimal. Which is the optimal solution for order of n time and order of 1 extra spaces. We can make it cleaner and shorter without changing the complexity. Complexity is still same. We can write it cleaner. That is fine. That is completely fine. No problem. Okay. So that is it for today, guys. I have added a couple of questions, guys. You can refer that questions and you can solve those questions. This question is also there over in Notion. Until then, bye bye. Take care. Stay healthy. जय हिंद. मिलते हैं अगले वीडियो में. I'll teach this rainwater trapping problem in the next video. I was about to teach, but the attendance today is very low. So maybe I'll teach that on Tuesday. I'll be teaching this solid principles tomorrow. So make sure that you are there. That is something more of a development side than on a non-dev side, like these logic sites. We'll see tomorrow. I don't know. we will update you.